Download this code from codegive.com, link in the description below. AI and NLP powered part sourcing for electrical engineering students. Introduction. In the field of electrical engineering, e.e., sourcing electronic components effectively can be quite challenging. With the rapid evolution of technology, the availability of parts, and the need for cost efficiency, leveraging artificial intelligence, AI, and natural language processing, NLP, can significantly enhance the process. This tutorial outlines how to implement AI and NLP techniques to automate the sourcing of electronic components for EE projects. Objectives: 1. Understand the role of AI and NLP in part sourcing. 2. Learn how to implement a simple part sourcing application. 3. Explore the integration of web scraping to gather component information. 4. Leverage NLP for parsing and understanding part specifications. Prerequisites: basic knowledge of Python programming, familiarity with libraries such as requests, Beautiful Soup, and pandas, understanding of machine learning concepts, optional. Part 1, Understanding the concept. Role of AI and NLP in part sourcing. AI can analyze historical data to predict future sourcing needs, optimize inventory, and suggest cost-effective alternatives. NLP can process and understand specifications from various sources, data sheets, online catalogs, and match them with user queries. Part 2, Setting up the environment. Make sure you have Python installed along with the necessary libraries. Bash. Pip install requests Beautiful Soup for pandas NLTK. Part 3, Web scraping for part information. We'll create a simple web scraper to extract part information from a hypothetical electronic component distributor's website. Example code for web scraping. Python. Import requests. From BS4 import Beautiful Soup. Import pandas SPD. Function to scrape part information. Def scrape _ parts, URL. Response equals requests.get, URL. Soup equals Beautiful Soup, response.content, HTML.parser. Parts equals. For item in soup.find _all, div, class _ equals part item. Part _ name equals item.find, h2, .text. Part _ price equals item.find, span, class _ equals price, .text. Part _ stock equals item.find, span, class _ equals stock, .text. Parts.append. Name, part _ name. Price, part _ price. Stock, part _ stock. Return PD data frame, parts. Example URL, replace with an actual electronic components page. URL equals https://www.example.com/electronic-parts. Parts _ df equals scrape _ parts, URL. Print, parts _ df.head. Part 4, Using NLP to process queries. Once we have a list of components, we can implement a simple NLP model to help match user queries with available parts. Example code for NLP processing. First, we will set up a basic function to process user queries. Python. Import NLTK. From sklearn.feature_extraction.txt import tfit vectorizer. From sklearn.metrics.pairwise import linear_kernel. Sample data, replace this with your scraped data. Sample _parts equals 10k ohm resistor, 1 UF capacitor, LM358 operational amplifier. BC547 transistor. Function to match user query. Def match _ parts, query, parts. tfitf equals tfitf vectorizer, .fit _ transform, parts. Query _ vec equals tfitf.transform, query. Cosine _ similarities equals linear _ kernel, query _ vec, tfitf, .flatten. Related _ parts _ indices equals cosine _ similarities.arg sort, -5::-1. Return, parts I, cosine _ similarities I, for I in related _ parts _ indices. Example usage. User _ query equals resistor 10K. Matched _ parts equals match _ parts, user _ query, sample _ parts. For part, score in matched _ parts. Print, f matched part, score, score.4f. Part 5, Conclusion. This tutorial demonstrated how to build a basic AI&NLP powered part sourcing application for electrical engineering students. By scraping part data and using simple NLP techniques, you can create a tool that helps efficiently source electronic components. Further enhancements. 1. Database integration, store scraped data in a database for persistent access. 2. Machine learning, implement a recommendation system using historical sourcing data. 3. User interface, build a web interface using Flask or Django for better interaction. References. Beautiful Soup documentation, https://www.crummy.com/software/beautifulsoup/bs4/doc. Scikit-learn documentation, https://scikit-learn.org/stable. NLTK documentation, https://www.nltk.org. This is a foundational guide, and there's much more to explore in the realm of AI and NLP for part sourcing. Happy coding!